The world of inspections is changing, and it's changing fast. So over the next few minutes, I'm going to walk you through what Mechanical Integrity 4.0 is, why it's so important right now, and how you can actually start using it. Let's get right into it.
First, let's just lay out the challenges that every single one of us is facing out in the field. We're all dealing with aging assets, right? Equipment that's been around for a while and just needs more attention. And of course, we're trying to do all this with really tight budgets. That means we have to be a whole lot smarter with every single dollar we spend. On top of all that, there's this huge pressure from operations to maximize uptime. And you know what that means? Fewer and shorter shutdowns for us to get our work done. But through all of this, there's one thing that is absolutely non-negotiable, and that's safety. There can be zero, and I mean zero, compromises when it comes to keeping people safe. So how in the world do you balance all of these competing demands? Well, this is exactly where Mechanical Integrity 4.0 comes in. And listen, it's not some new gadget or piece of software. It's a system, a new way of thinking designed for this exact challenge. It's all built on 3 core pillars. The first one is risk-based inspection, or RBI. This is all about using data to make smart decisions on where to focus your attention first. So when we talk about risk, we're really talking about 2 things. First, the probability of failure. What's the chance something could fail because of damage like CUI? And second, the consequence of failure. What actually happens if it does fail? We're talking safety incidents, environmental problems, you name it. RBI really helps us answer 3 very practical questions. The first one is the most basic. Looking at the design and how it's being used, what could actually fail here? The second question digs a little deeper into that probability. Okay, based on what we know right now, its condition, any damage, how likely is that failure, really? And the final question, this one's all about impact. If it does fail, what are the real-world consequences? Answering this one is absolutely crucial for setting your priorities. You see, when you put the answers to those 3 questions together in a systematic way, what you end up with is a fully justified inspection plan. You know what to inspect, when to do it, and you can explain exactly why it's the most important thing to do. All right, let's move on to the second pillar, which builds right on top of the first, digital workflows. This is all about getting away from messy paper trails and creating consistent, traceable evidence of everything we do. Think about the difference here. We're moving from a world of scattered data and handwritten notes that are all over the place to a clean system where all the evidence is consistent and easy to trace. It's a total game changer. So what does this look like in the real world? It means having a clean equipment list that everyone trusts. It means using standard digital checklists for every job. It means linking a photo of a finding directly to that piece of equipment. And it means having an automatic audit trail. For management, for regulators, the story is suddenly crystal clear. And all that clean data leads us perfectly into our third pillar, AI-assisted non-destructive testing. Now, this isn't about replacing inspectors, not at all. It's about giving us tools to help spot patterns in our data way, way faster. AI can give us some really powerful support. Think about analyzing UT thickness trends over time, or recognizing patterns in complex data, or even using predictive analytics to flag equipment that's heading towards a higher risk category before it gets there. But let me be perfectly clear about a very important rule here. AI does not, and it should not, replace good engineering judgment. It doesn't replace the codes and standards we all work to. So the crucial takeaway is this. You have to treat AI as a decision support tool. It's there to help, but it is not the final decision maker. The qualified human expert, that's you, must always, always be in control. Okay, so that's the theory behind it, but how do you actually get started with this stuff? Let's quickly walk through a simple 30-day pilot you could literally start tomorrow. First, just pick one problem unit. You know the one I'm talking about. List its known damage mechanisms and what could happen if they fail. Then, build a simple criticality ranking. High, medium, low. Easy. Based on that, define your inspection plan, digitize the forms you'll use, and then just make sure you review the results every month to keep the plan fresh. And what's the result of all this? Well, it's pretty powerful. You start making safer decisions that are backed by data. You get fewer of those nasty operational surprises. And your ability to show strong compliance becomes so much easier. When it comes right down to it, Mechanical Integrity 4.0 is probably the most practical upgrade you can make for managing your assets. It's just a smarter, safer, and more efficient way to look after the integrity of your whole facility. The only question left is, are you ready to get started?